Next session will include two key presentations from Korean two giant companies. Let me proceed with the first presentation. The first presenter is SVP Choi Sung-hyun from Samsung Electronics. Let me briefly introduce him. He was a professor of Korean Seoul National University. He joined Samsung Electronics 2019. He has led Advanced Communications Research Center. His presentation today is Prospect as Recent Progress Toward. Let's welcome SVP Choi.
Thank you. Thank you for your kind introduction. Could you please bring up my presentation? Good afternoon, everyone. I'm Sung-hyun Choi from Samsung Research, which is a research organization of Samsung Electronics. I'm currently heading advanced research and standardization of beyond 5G, 6G, and IoT connectivity within Samsung Research. Today, I'm very excited to share our vision and our recent progress towards 6G R&D, which we are preparing with the vision to provide the next hyper-connected experience to every corner of our lives in the following decade. I'm sure that all we are familiar with this kind of roadmap. Basically, we are up to 5G now. And it's very right time to start talking about 6G because 6G will be probably commercialized around year 2030, and it will take years to prepare for the next generation. To talk about 6G, we thought about what would be the mega trends towards 6G or in the year 2030. So the first one could be, there will be a lot of machines which will be connected by then. So as shown in this slide, we can imagine that there will be like 500 billion devices or machines will be connected, which should be about 60 times of the world population then. So that means, one of the main consumers of 6G should be machines, not just human beings. Moreover, the capability of machines can be far beyond that of human beings, so that what 6G should provide is far more than what 5G can do today. Well, we all know that AI ML is being utilized in many different areas and industry, and communication is not an exception. So today, AI ML is being utilized for network planning and network monitoring, root cause analysis and optimization and different areas. And given that AI ML continues to develop, fast develop, and given that communication network is far too complicated to manually monitor and optimize, I'm sure that AI ML will play a key role in 6G area. Actually, network is becoming open and open more and more. As you know, thanks to the improvement of CPU and GPU, network equipment is being softwareized and virtualized today. In traditional network devices where equipment was very hardware-centric and was based on special purpose hardware. But now, many of network functions are being implemented by utilizing general purpose servers and by utilizing virtualized environment and so on. And moreover, for this kind of environment, open sources are heavily used today. And another thing is, in old days, all the network equipments were kind of connected using closed interfaces, but now kind of opening up these interfaces is kind of happening now. So in the future, or that's happening now too, network equipments will be based on, in many cases, based on open sources and also with open interfaces. And this kind of trend will continue towards 6G as well. So now, what will be like 6G can provide in the future? So it's really hard to imagine what will be the future like, especially 10 years down the road. But we thought about it, and possibly some new services, including truly immersive XR, high fidelity mobile hologram and digital replica could be some examples of the 6G services. Of course, some forms of these services are available even today, but due to the lack of kind of, devices and also supporting communication technology, I think what's provided today is kind of not up to the customer satisfaction. And I'm sure that 6G will kind of realize all these services in a kind of full-fledged manner. So in order to provide this kind of services, 6G performance should be far beyond what 5G can do today. So I think in terms of high peak rate and user perceived throughput and also latency, I think as shown in this slide, the performance should be a lot better than what 5G can do. So in terms of user perceived throughput, it should be at least 10 times and so on. So to realize this 6G technology, I think we are all working on various candidate technologies. And this slide shows some of the kind of candidate technologies which we are looking at today. And today I'll show you some of recent progress which we made in terms of POC and so on, and also some of the kind of key technologies which we believe very important. So the first one is terahertz communication. Actually, you can see our demo and also real devices, which we did some recent, which we conducted some recent demo with these devices. So we all know that as new generation was introduced, higher and higher frequencies have been explored. So we all know that in 5G, up to millimeter wave band has been explored. And for 6G, to realize even higher data rate, we believe that we have to take a look at even higher frequency band, so-called sub-terahertz or terahertz. And also, thanks to wide bandwidth available in this frequency, by utilizing terahertz, not just communication, but also sensing capability, very fine-grained sensing capability can be also achieved. But there are a lot of inherent technical challenges with terahertz. As frequency increases, antenna RF loss increases as well, and also path loss increases too. And also, power amplifier power tends to decrease, and low noise amplifiers noise figure is likely to increase. So there are a lot of kind of bad news for us, but I think we need to tackle these problems to realize this communication part of 6G, especially to realize our vision to provide extremely wideband communication and so on. I'm not just saying that we have to look at terahertz only for 6G. We have to continue to look at low frequency bands to make it better, especially as shown in this slide. We have to take a look at the frequency bands which were explored as part of 4G, 5G already too. So this slide shows that the terahertz POC setup. By the way, this is kind of shown in the backside of this room too. So we implemented baseband processing and transmitter and receiver beamformers. And if you take a look at this, basically each of transmitter antenna and receiver antenna are composed of 64 antenna elements, and also 8 TX chains and 8 RX chains to support beamforming, right? So we did a kind of experiment the performance of this device in both indoor and outdoor environment. So this one shows that the transmitter panel is composed of CMOS transmitter and also indium phosphide external power amplifier. And this one is our baseband processing unit. And in indoor environment, at the distance of 30 meters, both transmitter and receivers are located, and we achieved 12 gigabps. And what's shown in here is the transmitter's orientation is kind of rotating. So even if the direction is kind of rotating, still the transmission rate is achieved. That means basically as the transmitter rotates, the beam forming is kind of rotated so that the kind of communication link between transmitter and receiver can be maintained in a stable manner. We had another set of experiment in the outdoor environment. So this is kind of parking lot of our research center in the US. At the distance of 20 meters, basically transmitter and receiver kind of had communication channel, and as shown in here, about 2.3 gigabps data rate was achieved. So the next topic is advanced duplex technology. We all know that FDD, TDD have been heavily utilized for 4G and 5G, and towards 6G, I think we have to look at even kind of better duplex technologies so that we can utilize the precious band more efficiently, and also so that we can extend the transmission coverage. So that includes XDD and full duplex. So this is XDD, which represent cross-division duplexing. By the way, we are proposing this technology as part of 3GPP Release 18, which is the very first release of 5G Advanced. So as shown in here, TDD kind of timeshares between uplink, downlink. With XDD, we use kind of uplink. We support uplink transmission by utilizing downlink time slots too. So apparently there will be some self-interference at the base station, but it's kind of key to cancel this self-interference at the base station. So the beauty of this is by increasing the uplink transmission time, basically uplink energy is kind of determined by power multiplied by time. So basically, since uplink transmission time is increased, we can imagine that uplink energy will increase so that uplink transmission coverage will increase as well. So the goal of XDD is to increase the uplink coverage in TDD band. Another side effect, the good thing is, because uplink transmission slot is available all the time, roughly speaking, the HARQ feedback delay is supposed to decrease so that the overall latency will decrease too. Another one is in-band full duplex. So we did recently millimeter wave based full duplex POC, and as shown in here, outdoor environment, 100-meter distance, and base station and mobile terminal, they do in-band full duplex. So compared with time division duplex, full duplex achieves about double of the total capacity. It's not exactly double, given that there still remains some residual self-interference, and also because of the protocol overhead and so on. It's not exactly double, but almost double. So by utilizing this kind of full duplex, we can increase the spectral efficiency. So what I'm trying to say is, towards 6G, we have to develop some kind of ways to utilize all different types of duplexing schemes at a given environment in an adaptive manner over time. So we all know that in this forum, in this event, both 5G forum and satellite communication forum are kind of co-hosting and co-organize this event. I believe that satellite will take a very important role in 6G area, so that we can provide 6G communication anytime, anywhere across the globe, from the South Pole to the North Pole. And actually, we all talk about UAM, and even inside flying car, actually 6G should be available. This is the last slide, by the way. So as I said, we are trying to utilize AI/ML technology for communication optimization. But today, AI/ML is utilized in a limited manner for system management, automation, and optimization. In 6G, we believe that AI/ML will be defined as part of 6G natively and will be used in a comprehensive manner so that the network performance, end-to-end performance can be optimized utilizing AI/ML technology. So that's it for today. So thank you very much.
Great, thanks, SVP Choi. It's a very interesting presentation. So it included a lot of 6G candidate technology. Is very interesting. So terahertz communication demonstration already available in this room also, and advanced duplex and AI for communication. A lot of key technology introduction was very useful for today's session, I believe.